Hello everyone, this is College Algebra, and this is Doug Schwartz talking. And let's do a couple problems today, and that will be enough, I think, of a review for the final exam, which is on Monday. Okay, I wrote an email about how long you have and all that stuff, so if you haven't seen that email, check it out. I probably wrote it a week ago. Okay, let's try this problem right here. Consider the quadratic function f of x equals 2x squared plus 7x minus 4. Indeed, it is a quadratic function because it is degree 2, as we can see right there. Alrighty, so let's do part A. Determine the x and y intercepts. That's a common question, to find the intercepts. It's always done the same way. For the x-intercept, you let y equals 0 and solve for x. And for the y-intercept, you let x equals 0 and solve for y. So let's do that now. So here's the function. I factored it. So that's a good step. To find the x-intercept, you want to factor that quadratic equation first, quadratic function. And that's the way it factors. Notice 2x times x gives you 2x squared. And then since that leading coefficient's not 1, it's harder to factor. What two numbers multiplies to negative 4? And you stop there. You don't say it adds up to 7. You only do that when the leading coefficient's 1. And 4 and negative 1 does multiply to negative 4. And if you FOIL that out, you'll get that. Okay, so we factored correctly. Now let's find the x-intercept. So you let y equals 0 and solve for x. And this is why you wanted to factor it. We can use the zero factor property next. So set each factor equal to 0. 2x minus 1, set it equal to 0. Add 1 to both sides. You have that. Divide both sides by 2, and you get that. And then set this factor equal to 0 right there. And that's what you can tell by inspection. It's going to be x equals negative 4. And that's ordered pairs, because these aren't just any x's. These are the x-intercepts, since we let y equal 0. And these are the x-intercepts as ordered pairs. Let's find the y-intercept, which is going to be easier. So to find the y-intercept, you let x equals 0 and solve for y. So I did it right over here. You can either write y equals, or if you want to get official, write f of 0, because we're getting all x's equals 0. F of 0 equals 2 times 0 squared plus 7 times 0 minus 4. And what does that equal? Negative 4. So as an ordered pair, it's going to be that. Okay, let's try part B. And that is determine the vertex of the parabola. So notice for a parabola in standard form, you have to use this formula of, let's see, let me write down the formula, because we want to find the vertex of the parabola, and then state whether the function has a maximum or minimum value. Okay, so v sub x, which is the same thing as h, right? The x-coordinate of the vertex of this parabola. It's interesting to know that parabolas have a vertex. It's either going to be the lowest point or the highest point, depending whether it opens upward or downward. So v sub x, that's a v there for vertex, and that's the x-coordinate. That's what that means. Or you can call h equals negative b over 2a. That's the little formula. So you want to make sure you have that handy when you do this final exam. And so what is an opposite b, or negative b? Let's go back to the original function. And remember, this is a, that's b, and this is c by convention. So opposite b is going to be negative 7 over 2a. What's 2 times a? A is 2 here, the coefficient of the x squared term. What's 2 times 2? 4. So there it is. That is the x-coordinate of the vertex. We want to find the full vertex, so let's find the y-coordinate of the vertex, which you can call k, or you can also call it v sub y. And how do you find the y-coordinate of the vertex? It's basically going to be f of, and whatever you get for the x-coordinate of the vertex. We got negative 7/4, so that will lead us to the y-coordinate of the vertex. Just finding that. So all of these three things are really the same thing here. So plug in negative 7/4 for all x's in the original function. It's kind of like a table of values, you know. You have an x and a y. We want to come up with a point on that parabola. What happens if you let x equal negative 7/4, which is the x-coordinate of the vertex? That will force out the y-coordinate of the vertex. So let's do that. So it's going to be 2 times negative 7/4 all squared plus 7 times negative 7/4 minus 4. So what is that going to be? 2 times negative 7/4 squared, that's going to be positive. And you square the numerator and the denominator, so you get 49/16 minus 7 times negative 7/4. What is 7 times negative 7/4? Make that 7 over 1. And isn't that going to equal negative 49/4? That's how you multiply fractions. You don't need a common denominator. Just multiply the numerator straight across and the denominator straight across. So that's why that's a negative 49/4. And then you got to preserve that minus 4. And what's 2 times 49/16? You can cross cancel the 2 with the 16. So that becomes 49/8 minus... let's come up with a common denominator. Let's make that an 8. So multiply top and bottom by 2, and you get 98/8. It's the equivalent fraction of that one. And then minus, instead of calling it 4, let's use that same common denominator of 8, and another name for 4 is 32/8. So we have that. Now, how do we subtract these three fractions? Keep the denominator the same. And what's 49 minus 98? Negative 49. What's negative 49 minus 32? Negative 81. So there is the y-coordinate of the vertex. So what's the vertex as an ordered pair? Right there. And is this a minimum or maximum value? It's a minimum value because isn't A positive, which implies the parabola opens upward? And isn't that vertex a minimum? Notice there is no maximum, right? Because it's going toward infinity, which we want a real number answer for these maximum or minimum questions. So it is a minimum. The y-coordinate is actually going to be the minimum value, negative 81/8. But they just want to know, is it a minimum or maximum value? And the answer is a minimum, since the parabola opens upward. And then finally, the last part of this question is, on what x intervals is the function decreasing? And it'll be helpful to draw a rough sketch. We know the parabola opens upward because A was positive. We know the vertex is right here, which is roughly right here. And where is it decreasing? So you read a graph left to right. Isn't it going down from negative infinity right up to that vertex? Or right down to that vertex? And you always use x coordinates. It even says on what x intervals. So you go low to high with intervals. So that's why it's decreasing. This parabola is decreasing on negative infinity to negative 7/4. I should have labeled that vertex as negative 7/4, negative 81/8. Okay, let's try the next problem. Okay, it's another quadratic idea here, and we're going to really see the power of the vertex. We can answer this tough-looking question. Gary has 600 meters of fence to enclose a rectangular dog pen. Express the area of the rectangle as a function of x, where x is the length of the rectangle. So here's a quick picture. Length and width, or call it, instead of L and W, let's call it X and Y. We know the area of a rectangle is length times width, or X times Y in this case. And notice, part A, it helps you to get the final answer, because we want to make this function in terms of one variable. That way we'll get a nice quadratic function in one variable, then we can use that vertex idea. So, let's use all the information given. 600 meters of fencing we have. That sounds like perimeter. Distance around is 600. And opposite sides of a rectangle are equal. So that's x and this is y. So what's x plus x is 2x. And what's y plus y? 2y. And that equals 600. So that's a nice equation. So you got to be on your toes with these problems. Okay, so we got two formulas, the area and the perimeter. And let's notice this perimeter is in two variables. I want to see it in one variable. First thing I want to do to make life simpler, take this perimeter equation, divide both sides by the greatest common factor, 2. So we have 300 equals x plus y. All we did was divide both sides of the equal sign by 2. And that's called the division principle of equality. Now let's solve this for y, because I want to get y in terms of x. So subtract x from both sides, and you have this. So that's nice. And now let's write the area function. Let's write area as a function of x. So instead of writing area equals x times y, that y we don't like that, see that y. Let's write a of x, or you can write even a equals, but it looks better. A of x in function notation. A of x equals x times, instead of writing y, doesn't y equal 300 minus x? So that's good. That's in terms of one variable. Let's use the distributive property next and put it in standard form. So we have this. And now it's in standard form, and we should all be thinking of that formula for the x-coordinate of the vertex. Negative b over 2a is the x-coordinate of the vertex. That's going to come in handy for this part b. For what value of x is the area the largest? So in other words, what should that length of the rectangle be? How many meters? So that we get the maximum area. That's what the x-coordinate of the vertex tells you. The ancillary information. So let's find the x-coordinate of the vertex. So h, or you can call it v sub x, equals negative b. Make sure you use this function right here. Negative b, so that's going to be negative 300 over 2 times a. What's 2 times negative 1? Negative 2. So what's negative 300 divided by negative 2? A positive 150. And so that's the x-coordinate of the vertex right there. So the length has to be 150 meters. And then part C, what is the maximum area? That's the y-coordinate of the vertex. Remember, the y-coordinate of the vertex answers the macho question. What is the maximum or the minimum? In this case, maximum. To figure that out, then, let's look at this one right here. So make sure you use the area function, because we want to find the maximum area. And we're going to let x equal 150, because that's what we got in part B. So a of 150 equals, so plug in 150 for all x's. So what am I going to plug in for that x? 150. So preserve that negative sign. So negative 150 squared plus 300 times 150, which we have right here. So, order of operations, you got to square the 150 first and then make it negative. So we have that, and then what's 300 times 150? That, and when you add them up, you get that. So that's the maximum area. Turns out all quadrilaterals, if you want to find the maximum area of a quadrilateral, it will always be a square. So that's why this idea works too. Length and width are going to be the same. So 150 times 150, which also equals that. And we are done at 12.5 minutes, or 12 minutes and 53 seconds, I should say. All right. Good luck, everyone. Bye-bye.